The human race has taken tremendous steps. We have achieved the earth-shaking, the groundbreaking,
It's one small step for man,
and we have left historical marks upon the heavens.
We choose to go to the moon.
From one success to another, we have built a strong foundation of what's possible for space exploration. It's now time we take the next great leap. Mars. We are the FACC 400 video team analyzing case study 2. What is the potential of the human race to colonize Mars? Colonizing Mars would be a huge milestone for the human race, but how we go about it, rather than how soon, is the more important question. In this film, our team tackles the challenges from the ethics, the technology, biomedical issues, crew training, behavioral issues, and the pros and cons of settling on Mars.
Ever since the first ever Mars landing in 1976 by NASA's Viking 1, Mars landing has been proven feasible. Almost half a century later, the rapid advancement of technology is making colonizing Mars possible. However, there is much more than how do we land, but also how we should settle. To build a self-efficient colony, we must find ways to transform Mars's natural resources into usable material. With such a considerable amount of unexploited minerals, there is a difference between mining to sustain the colony and mining to make a profit, and the boundary between the former and the latter is very subtle. We must recall the primary reason behind Mars's colonization is the exhaustion of Earth's resources from overexploitation, of course. If Mars simply seen as a safety net to save the human race from extinction, then without truly changing the way humans treat their habitat, we will eventually exhaust Mars's resources as well, causing irreversible damage to its geography and potentially its ecosystem. That will be a serious issue to debate about if humans can even survive the harsh conditions of the new planet.
There might be a few biomedical issues during the travel from Earth to Mars. The first one is radiation. Biological effect of radiation includes effects that may cause acute radiation sickness to NASA and may occur within hours of exposure or might cause cancers after exposure to radiation in 2 or more years. The second one is burn loss. Exposure to microgravity produces progressive changes, and the most serious being those imposed upon the skeletal system, which shows no sign of resolution. It is still a matter of discussion whether some of them might lead to permanent and irreversible damage. During their travel to Mars, the crew may lose strength and size in the muscle used for standing, walking, and posture because of a process known as muscle atrophy. There are no effective non-exercise countermeasures, which means crew members must spend 2 or 3 hours every day for exercise. Other biomedical issues include cardiovascular changes, neurovestibular, and immunological. Behavioral issues may also exist during the travel. Due to isolation and confinement in the environment of the Mars expenditure, it might cause automation and displacement between crew members. It may also produce new psychological challenges never experienced before. Surprisingly, positive effects are also experienced when astronauts wear the Earth below.
A mission to colonize Mars would imply many risks, which could prove to be devastating for a small society. Some of these risks include events like sandstorms, pandemics like COVID-19, and social conflicts, which could lead to resource depletion or worse. Social conflicts stem from behavioral conflicts, which is a very common type of conflict. During these long journeys and stressful environments, arguments are very likely to spark due to personality mismatches. This poses a serious problem to a colony and to the crew selection process, as no number of tests can say with certainty if 2 or more individuals get along. There are so many factors to consider when putting together a crew, such as roles, size, gender composition, and more. Psychological training becomes crucial in order to develop interpersonal group dynamics within the crew and with ground control personnel. To help with developing this training program, certain studies are being conducted across the world, such as the High Seas Project. In this project, a chosen group of 6 NASA-funded researchers spent 8 months in isolation in a geodesic dome on one of Hawaii's volcanoes to study human behavior and interpersonal conflict in long-term space exploration missions. The study will assess the psychological difficulties associated with living in isolated and confined conditions for an extended time. If interested, you can tune in to Gimlet's podcast, The Habitat, chronicling this experiment from the moment the crew set foot in their habitat, communicating their discoveries, their frustrations, and their evolving and devolving relationships with each other.
Here are some pros for settling Mars. For any species, survival is the first priority. In case the Earth is ever destroyed by climate change, nuclear war, or an asteroid collision, putting humans on Mars will ensure our existence even after the Earth is gone. Scientists believe that water, and thus life, exist on Mars. The Mars life theory suggests that life came from rocks that originated on Mars and made their way to Earth. To prove this, we must dig deeper into Mars than the rovers are capable of. Preparing for a Mars mission would force humans to make new discoveries in science and technology that can help improve life on Earth. These advancements can be adapted to other fields like medicine and agriculture. Mars has many raw materials that can be utilized for further space exploration. Its resources can be used to construct space vehicles, and it can become a launch pad to other planets. Here are some arguments made against settling Mars. There are dangers associated with traveling to a new planet. Health issues such as exposure to high levels of radiation and the degenerative effects of microgravity that can lead to muscle and bone atrophy. The cost of sending humans to Mars is estimated between $20 and $450 billion. Some argue that this money can be better utilized on Earth for things like education and infrastructure. Settling on Mars could destroy any Martian life that potentially exists. Humans can upset the natural order of the planet by bringing in Earth microbes and viruses. We have problems here on Earth that must be addressed. Instead of pouring money, time, and resources into a Mars mission, these can be utilized to tackle world problems like climate change, poverty, and natural disasters.
NASA has announced plans to send humans to Mars by the 2030s, but is this really a good idea? With all the ethical, financial, medical, and human factors to consider, this idea of colonization serves as a great question in the science community. We need to have the right mentality before we venture into Mars. If we want to create an Earth 2.0, we must truly bring a better version of what we have here to there.